Another reason that acceleration can be kind of confusing is that when you're accelerating, you can accelerate faster or you can accelerate slower. And that kind of terminology doesn't really make sense. How can you speed up more slowly, right? What does that mean? So we're just going to look at two rates of acceleration here. Our first one is 1 meter per second, and the other one is 10 meters per second. And we're going to just kind of talk about these two and compare them before we get any more complicated. So I've set up a little data table. On the left-hand column here, we've got time in seconds, so how long you are accelerating for, right here. And here's your velocity, meaning how big is your jump, right? So in the first second, you will have accelerated up to 1 meter per second. As every single second goes by, right, this is time passing, your velocity, your speed, is going to go up by a jump of 1, right? Each of these numbers goes up by 1 meter per second, right? Every single one of those jumps is just going up by a unit of 1. So every single second that you continue to accelerate for, you will go 1 meter per second faster. After 100 seconds, you'll be going 100 meters per second. After 1,000 seconds, you'll be going 1,000 meters per second. So it just works linearly in that every single second you accelerate, you will go 1 meter per second faster. Now over here, as you can tell already, for every single second that you accelerate, you will go 10 meters per second faster. So after the first second, you're going 10, then 20, then 30, then 40, then 50 meters per second. And the reason for that is every single second you go up by a jump. Remember, we're talking about this box here representing our jumps of 10 meters per second. Going from 10 to 20 is 10, a jump of 10. Going from 20 to 30 is another jump of 10, 10, 10, right? Which is all represented up here in our rate of acceleration. Every second, you go up by 10 meters per second. So that should be pretty easy, and that should be something that we're okay with at this point. But let's take a look at a couple of these scenarios down here. So again, we're going up by every single second, right? We've got all of our seconds listed out here. And at first, we're going up from 10 to 20 to 30. So what is our rate of acceleration there? Easier way of figuring that out is saying, okay, how big are our jumps? Well, from here to here, our jump is 10. From here to here, our jump is 10. Each of those is happening in 1 second and 1 second. So that tells you that our rate of acceleration for these first 2 seconds is 10 meters per second squared. Here, however, we go up by a jump of 5 meters per second. Then another 5 meters per second. So, are we accelerating still? Yes. We went from 10 to 20 to 30 to 35 to 40. Our speeds are still getting bigger. However, they're going up by a smaller increment. Rather than still going up by 10 meters per second, they're only going up by jumps of 5 meters per second. Are those numbers still getting bigger? Sure. You could go up from 40 to 45 to 50 to 55 to 60, and if you continue at that rate of acceleration, eventually you could still be going 1,000 meters per second. It would just take you a little bit longer than if you were going up by jumps of 10. So you are still accelerating. Now you're just doing it at a rate of 5 meters per second per second. Then what we see is that your rate of acceleration actually drops a little bit more and is now only 1 meter per second. And another 1 meter per second. Are you still getting faster? Sure. 41 meters per second is still faster than 40 meters per second, and 42 is bigger than 41, and if we kept going down to, or going up rather, to 43, 44, 45, right, those numbers are still getting bigger every single second. So you are still accelerating. You do have positive acceleration, but your jumps are only going up by 1. So what we see here is that you started going out, accelerating at 10 meters per second. Then you were accelerating at 5 meters per second, and then at 1 meter per second. In each of these 3 instances, you're accelerating. Your speed is getting bigger. What's different is that here, you're going up by jumps of 10. Here, you're going up by jumps of 5. And here, you're going up by a jump of 1. So you're accelerating, just not as quickly as you were when you were going up by jumps of 10. Okay, so that's how you can accelerate. Are you accelerating? Yes, yes, and yes. But in this first instance, you're accelerating very quickly. Here you're accelerating at a decent rate, and here you're accelerating a little bit more slowly. Are you still accelerating? Definitely. But you're accelerating, you're getting faster more slowly. Now let's take a look at this on the other side. So if we come over here and we're looking at these numbers, again, we're going by every second, right? 1 second, 2, 3, 4, 5, 6, 7, 8. And we're looking at our velocities. But our velocities are now going down from 100 to 90 to 80. So here, our rate of acceleration is actually going to be negative 10, right? They're going down. Our velocities are getting smaller by jumps of 10. So for there, we would write that our rate of acceleration is negative 10 meters per second per second. So we're still accelerating, but we call this negative acceleration or deceleration to talk about this negative sign, meaning that our speeds are going to get smaller. We're hitting the brakes. Now we're jumping only by 5. Again, by 5. So that tells us that our rate of acceleration is negative 5 meters per second per second. And then here we go down from 70 to 69 to 68 to 67. That tells us that we're going down by negative 1 meters per second in each of those instances. So again, here we are slowing down fast. Here, you're slowing down a little bit more slowly. A little more slowly. And here, you're kind of slowing down slowly. Which is weird to say, right? You're slowing down fast. You're slowing down slowly. What does that really mean? Well, if you think about in a car, if you tap the brakes, you slow down just a little bit. If you slam on the brakes, you slow down very, very quickly, right? If you see that, somebody just like hit their red lights ahead of you, you might just tap your brakes because you're not sure what they're going to do. So you start to slow down just a little bit. But if you see an accident up ahead, you're going to slam on those brakes really, really quickly to try to slow down as fast as possible. So in that instance, here we are slowing down by a jump of negative 10. Here, on the other hand, we're slowing down by jumps of negative 1. Are you slowing down in both cases? Yes. But in this case here, you're slowing down really, really quickly. Every single second that goes by, you're slowing down by 10 meters per second. In this case over here, every single second that goes by, you're only getting slower by jumps of negative 1. Right? You're going down from 70, 69, 68, 67, 66. Tiny little increments of getting slower. Whereas if you really slammed on the brakes, like right here, you can get slower by jumps of 10, negative 10 in this case. So you can slow down fast, or you can slow down slow. So really what we're talking about is how big are those jumps that you're slowing down by. Is it a negative 10, a really fast deceleration, or are they jumps by negative 1 or 0.5, right? Tiny little increments that you're slowing down. So if we wanted to put some words to these, this would be, excuse me, speeding up quickly or fast. And down here would be, you're kind of speeding up more slowly, right? Are you still speeding up? Yeah, you're getting faster by jumps of 1, but you're just doing it a little bit more slowly than you were up here, right? In this first case, you're getting faster much more quickly. Here, you're getting faster, but only small little increments. So all of this comes down to the increment of acceleration. How big are those jumps, right? And I think that's the thing that we need to keep in mind all the time is if those jumps are bigger, you're either going to be getting faster at a faster rate, or you're going to be getting slower at a faster rate. But if those jumps are tiny little increments, then you still might be getting faster, you're just not going to be doing so as quickly. And if you're actually slowing down, if it's negative 1, you will still be slowing down, you'll just be doing it at a slower rate than if it was -10 or -100, right? The bigger that increment, that jump gets, the faster that you will be speeding up or slowing down.